So the first question you see here is, why is information about carbon critical to understanding the molecules of life? What did I say repeatedly? Carbon's the backbone of all, carbon's the center of all biological molecules. We said there's several elements that we talked about: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. All of the biomolecules have carbon. All of them have hydrogen. All of them have oxygen. Like, all of them. There's none of the elements we talked about, none of the molecules, none of the four, not lipids, not nucleic acids, not proteins, and not carbohydrates. None of them were lacking carbon. And it says, is the only element that can form triple bonds. Well, that's not true. That's not true. First of all, we didn't talk about triple bonds. That's number one. And secondly, we said carbon forms 4 bonds, not 3. And thirdly, we know nitrogen forms 3 bonds. So it makes no sense. So this B should not have been even in your wheelhouse. It's the result of vitalism. We haven't talked about vitalism. This is obviously a distractor. So if you chose that one, I guess I'd have to ask why you chose it. Because it sounded good? And it is able to cause dehydration synthesis. Carbon's not involved in dehydration synthesis. Dehydration synthesis is between hydrogen and oxygen, right? To make water. So this doesn't make sense. It's involved in that the bond between the carbons are made, but that's not what they're asking. So realistically, the only possible right answer here is A. The only possible right answer. And if you've been paying attention, for the last 3 weeks, we've been talking about carbon at the center of everything. Right? Organic chemistry is a study of compounds containing. If you had this choice, it says organic. What do you think of when you think of the word organic? Natural, right? Living, life, right? So that's really not the origins of it, but that's fine. Organic means it has to do with life, and that at least I hope you know, we haven't talked about hydrogen or helium. Helium should be out of your brain. If you chose B, again, why? Oh, did I give you your answers? I haven't given your answers back. When we're looking at an amino acid, you're talking about an amine group. I told you had to know what they were. Literally 5 of the questions on here were things I told you over and over again. Make a index card on it. Know it. For 3 weeks, I've been begging you to do it. Amine, NH2, 2 hydrogens and a nitrogen. Carboxylic acid, 2 oxygens and a hydrogen and a carbon, COOH. An amino acid, an amine group, an acid group, and then a side chain or R group, a variable. Then the lipid is made mostly of carbon and hydrogen. So when we look at the characteristic of carbon that makes carbon atoms that most contributes to the importance of to critical biological molecules, I hope you see that it's the ability to form 4 bonds. 4 bonds. I said it 100 times. I don't know what else to tell you. You should know that. Carbon does not make 8 bonds. No, it does not. Carbon does not make 8 bonds, so you can get rid of that. The ability to form hydrogen, carbon, and covalent bonds doesn't make any sense. Like, carbon-hydrogen bonds are covalent, so that did not make sense. The ability to choose the type of molecule to produce, carbon does not choose. It's not about a choice. So the only possible answer is the ability to make 4 bonds. Why are fossil fuels such as gasoline considered organic? Again, I never mentioned organic really in class. We never focused on that, so I made this extra credit. But if you think about organic, you probably think of life. And what's the element that's involved in life? It's carbon. Anything that makes organic, it has to be carbon. Now, some people may have chosen carbon hydrogen. That was a good guess. But it's wrong. What makes anything organic is that it contains carbon. All right. There are 2 forms of hydrocarbons. What do we talk about when we talk about hydrocarbons? Does anybody remember what we talk about when we talk about hydrocarbons? I hope you remember hydrocarbons are carbon and hydrogens. They're lipids, carbon and hydrogen. Mostly carbon and hydrogen. Even right now, as I'm recording this, as I'm going over questions that I'm telling you are going to be on the next test, I have some people in the back looking down at their feet, looking down to the side, chewing their gum, talking. They're not focused. Not focused. And that's what concerns me. Going over the answers on the test, people are not paying attention. There are 2 forms of hydrocarbons. Which is the most able to accept new atoms and why? This is not something you learned. This was extra credit. If you made a guess and you pick C, unsaturated hydrocarbons, they have double and triple bonds that can be broken, you were correct. It's okay if you didn't choose it. It's not something you learned. I didn't mean to put it in the test. Yeah. It's not on your test? Good. I took it out of your test. But the other class had it in theirs. So some people had it and they kept it. And it's just, unfortunately, the way that I have things I'm doing, I can't, not right now. I'm sorry. There are many different types of proteins created by bonding amino acids together. Why are there, how many different amino acids do you have? How many different of these do you have? 20. That's good. That's right. What makes 20 what? What makes them different? What makes those 20 different? The R group. Excellent. The side chain or R group. Perfect. So when you're looking at the amino acid, you're looking at the R group as being different. But what's going to make a protein different, let's look at the question, is it that each protein is composed of 1 or 2 different monomers? No, there's 20 different monomers, right? 20 different amino acids, not 1 or 2. Each protein is exactly the same monomer? No, we just said there's 20 different ones. So that's not true. You understand that the monomer they're talking about is the amino acid, right? They use the word monomer for proteins, it's amino acid. Each protein differs in the arrangement of the amino acid? Yes. So if you have one protein that has R1, R2, R3, R2, another protein might have R18, R19, R20, R1. So the order of the amino acids changes the protein. The difference between your fingernails and your hair is which amino acids make it up and in what order are they in. That's it. Yeah.
Can you go back to the paper on the screen?
Yeah.
Question 5 and 6.
Yeah. Like that?
They're not the same.
Will you be
They're not going to be the same. I will be posted on Schoology. They're not going to be the same because everybody got a different test. Different people got different. I don't give everybody the same test. That doesn't make sense to me because then one class tells the other. I try to avoid cheating as best I can. Let's go on to the next questions, the next set of questions. This should have been recorded. Unfortunately, I posted it already and it didn't record for whatever reason, so I'm recording it again. Monomers are bonded together by which of the following processes? My God, there's at least one person that came to me and said, I've never heard of dehydration synthesis. And I'm like, really? I'm like, seriously? Because how many times did I have to say it? We're trying to link these two together, trying to link the carboxyl group here, the carboxylic acid group here to the amine group here. I drew it out. I did the same thing that I did with I'll do it again with the glycerol. I said, look, how do we connect these two? If this has 4 bonds, remember me counting out the 4 bonds? I said, look, 1, 2, 3, 4. Do you remember me saying that? Yes or no? Yes, good. So there's 4. Here, I said, look, nitrogen has 3, 1, 2, 3. Nitrogen can only make 3, so they have 3. And you're trying to link them together, the carbon and the nitrogen. How are you going to be able to do that? What do you need to do? That's right. You have to remove 2. You have to get rid of these bonds. And the way you do it is you get rid of this, and you make water. And I said, look, removing water, another word for removing is dehydration, right? Dehydration. And what am I doing? I'm making something new, so it's synthesis. And you can go back and look at the videos that we did in class, and you'll see that what you're doing is you're linking them together by linking the carboxyl group of one amino acid to the amine group of the other. And I said this is called, I said this is called the peptide bond. I said that's called the peptide bond, and in order to make that bond between the two monomers in a protein, you have to remove water. We said dehydration synthesis. I said, look, if we want to connect 2 sugars, I literally use this example. So I'm going to sketch it out. I'm not going to draw the details, and it's probably going to be something wrong with it, but I'm just going to draw it quickly. If I want to connect these two, this sugar to another sugar, and I want to make a connection, and I don't remember the connection between the two. I want to make a bond between them. I got to remember that when I zoom in, the one sugar has an OH sticking out of it. The other sugar has an OH. Every one of these carbons has a hydroxide on it. How do I bond the two together? I have to get rid of something. I have to get rid of what? Water. It keeps repeating itself. The OH and the H needs to leave, just like we did in the lab. We made water in the lab for a reason. You make water, those two leave, and what you're left with is a bond between the oxygen and the carbon. So what's left is this bond between an oxygen that links the two together. How did that happen? You got rid of water. It's the only way that works is if water leaves. We call that dehydration synthesis. We can look at lipids. They're not monomers. They don't have polymers. They don't have polymers, but they do. In order to build lipids, you have to build them using dehydration synthesis. I'm drawing this again for like the 5th time, I think, or something like that. This molecule, I've drawn it, I think, 5, 6 times. This is the molecule glycerol. And we said we have these things called fatty acids. And why do we call these things acids? Because they have a carboxylic acid group on the ends. And a fatty acid has It's a long chain. It's a fat, so it's a long chain. It's a hydrocarbon. I'm going to put ... It's a hydrocarbon, and you had this in your study guides, and you had this on the explanation of the study guide, and you had this in the class lessons, and etc.
So lipids have carbon,
Carbons, fatty acids, a fatty acid is a fat, which is this carbon chain, and an acid group, which is the carboxylic acid. So we call it a fatty acid. That's it. Remember, it's either saturated or unsaturated. I'll refer you back to the class notes if you need a remembrance, or you can come and see me during my office hours and we can go over it. But I don't want to redo the whole lesson because there's a lot of questions to answer. I would love to do it again. We can do it maybe, as I said, during office hours. So what happens is the OH and the H leave, and they leave as water, right? Dehydration synthesis. And what you're left with, if you do 3 of them, if you do that 3 times, what I just did 3 times on one glycerol molecule. So you got rid of 3 waters, and you connected the C, and that's double bond O, and then a bunch of C's. I'm not going to put all the H's. And then another C, double bond O, and a bunch of carbons. In fact, I can do it the way they do it in the study guide, the way we did it in the study guide, and that would make a lot more sense if we remember every point on the line, every connection between lines, every point is considered a carbon. We can do this, right? So that's a representation of a carbon, 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 carbon. I can do the same thing with all the fatty acids. They can be different lengths. They can have different number of but they all have the connection of the carboxylic acid group. And sometimes you get this going on. And this is what? What's that there? It's a double bond in the fatty acid, which bends the fatty acid. Do you see how it bends? So here you have an example of a bending of the fatty acid where these are straight. And if you go back and again look at the lessons, we saw that when you have a bent fatty acid, they don't lay down as well with each other. So they stay liquid at room temperature, where the saturated fatty acids, they can lay down flat and they become solid at room temperature. And these are called saturated fatty acids. Why are they called saturated? Because every bond is filled with a hydrogen, where the unsaturated means that you have some double bonds. Now, that's just a quick review. We went into it in detail in class. And again, and the study guide. Yeah?
So when you have a double bond in lipids, it means unsaturated.
That's right. Double bond means it's unsaturated, and it's going to mean it's liquid at room temperature. So let's go ahead and zoom in on the test question, now that we went through all that, and say, what best describes here. For which, this is not something you'd know, so these, to be clear, these were extra credit. I'm not going to go over it because we're running out of time. We can go over it after class if you like. The shape driven by chemistry, shape dictates function. Again, that's not something we covered in class. But here, we know the side chains are going to vary, so we know that that's the case, correct? Yes? Did I skip some questions? I think I did. Yeah. All right. So here, give me a second. Hold on to that question. Monomers are bonded together by the following process: dehydration synthesis. I just showed it to you. Which of the following lists correctly identifies the characteristics of structure of amino acid? I hope you know it's NH. It should be NH2 really, not NH3, right? It should be. Yeah, it should be a 2, but it's still the best answer. This should be NH2 because you know for sure it's not NO2. You know for sure it's not ammonia, and you know for sure it's not N2OH. So really the best answer is B. But you're right, that should be NH2. The people that made this test messed that up, that's fine. But that is still the best answer. Multiple choice questions are about what's the best answer. And when you look at 9, it says the proteins are formed from something, and the amino acid of one amino acid combines with the something else of another amino acid to form a what? So when we look at it, I just did it. I literally just did it. So I hope you saw that it's the acid of one amino acid and the amine of the other to form not a monopeptide, but a polypeptide. So the answer here is this. So again, when we look at what we just drew, when we make this, well, this would be a dipeptide, but if we connected a bunch of these together in a big long chain, if we put, I don't know if we still have that drawing here somewhere. No, I do not. But if I took a bunch of these and I said one amino acid and I put a bunch of these amino acids, I drew them just like this with yellow dots just the other day, and I said we connect them together. If we connect together with these peptide bonds, we would call this a polypeptide because they have a bunch of peptide bonds. A poly means many. So this is what makes it a peptide. The 2 amino acids connected, one acid group of one amino acid to the amine group of the other. Acid group of one to the amine group of the other. All right. So that's what makes that one. That one, they're 20 different. How they different from each other? How are they different? What makes the one amino acid different from the other? You said it already. The R group or side chains, right? So again, these are extra credit. We don't have time to go over them.
So side chains is the same thing as R group?
Yes, side chains the same thing as R group. So that's a good point. You should make sure you make a note of that if you missed it the first time we went over this. Now here it says proteins play many critical roles in organisms. Which of the following pairs? This again is not something I expect you to know right now. You will need to know these though. If you're looking at these extra credit questions, expect them on the next test. Because we're going to be covering this material starting tomorrow.
But we're not doing 13?
Did we not? Did I miss 13? Let me go back. Hold on. 13 was extra credit, that's why. All right. It may be different on yours, so if the question looked different. I don't want to give you a test question to count for points if we didn't cover it in class. I don't think it's fair. So everything I do, I try to make fair. Which really hurts me sometimes when people say things are unfair when I try very hard to make it fair. All right, 14. Proteins play a critical... Yes, this is extra credit. We're not going to worry about that right now, but you will see it on the next test. Over the next week, we're going to go over these topics that I'm not mentioning here. This one is not extra credit. This one you should know. Carbohydrates consist of carbon, hydrogen, oxygen. And which is a formula for it? What's the ratio between carbon, hydrogen, and oxygen?
CH2O.
1 to 2 to 1. 1 to 2 to 1. It's 1x to 2x's to 1x. 1 to 2 to 1.
That doesn't make sense though.
Why?
It does.
Because it's a variable. No, because it's 2x.
In math, if it's just one X,
It should just be x.
I could even see somebody choosing B, honestly.
It should be x, x, x. Because the variable should be x.
No, because you remember for every one carbon you have 2 hydrogens and 1 oxygen. I could see someone saying this if you really wanted to, but my problem with this is you're not putting the X in front of all three of them, so I don't like that one. I honestly, if you chose A or B, you're on the right track. You're fine. It was just a mistake, which is covered by the extra credit in the curve. C. Yeah, no, that would be wrong. I understand why you chose C, except you don't remember. It's just you didn't remember. There's 2 hydrogens for every 1 carbon. Yeah.
That's not my I got it mixed up.
Say what now?
That's not my 15.
Yeah, they're not the same numbers. So everyone, if you mess this up, I understand why. It looks weird. I get it, but you're gonna have to. You're gonna find weird questions, guys. You're gonna have to take the Ohio State exam. I don't write the Ohio State exams. I don't know what's gonna happen. You're gonna take ACT, SAT questions. I don't write those questions. You're gonna have to take AP exams. You're gonna have to take college classes in the future. I don't know what kind of crazy things you're gonna see. You're gonna have to be able to figure out the best answer every time you see a question. So this is really good practice, okay? The monomer of polysaccharides is a blank. What is the monomer of polysaccharides? By this point, everybody should know monosaccharide. If that's a problem for you, you need to see me during my office hours, please. However, if you look at it, there's 2 possible answers if you know it's monosaccharides. If you know it's monosaccharides, you know it's not A or B. Because that says monocarbohydrate, and this says disaccharide. You know A and B is wrong. So it's either C or D. But it says table sugar. We went over numerous times that a disaccharide is what table sugar is, which is something called sucrose. Oops, that was crazy. So it is, the answer is in fact C, yes. So when comparing proteins and carbohydrates, the following similarities can be identified. Both consist of linked monomers via a process called dehydration synthesis. I mean, this is like the 3rd time we mentioned dehydration synthesis on this test. If you didn't remember dehydration synthesis, then it kind of hurt. But guys, we went over it. 3 types of polysaccharides are particularly important in living things. You didn't have to know this. You should. I could have counted this, but I've made it extra credit. I did talk about it, but I didn't think we emphasized it enough. But the answer was starch, and starch is used in plants for storage. Remember I said starch is sugar in potatoes and in yams, and then we dig them up out of the ground to make our sugar that we eat, and we also eat them for carbohydrates. So plants store them, though, for themselves, not for us. And then we use the glucose for energy. Remember, I went over and over again, that thing you're sitting on, that wooden stool, is made of sugar, but you can't eat it because it's in a form that's connected like this. By the way, this is cellulose. It's connected like this crazy amount of connections, and it's very strong. It's hard to break them. So you need a special enzyme to break them. We don't have that enzyme, so we can't break them. No, you did not have to do this one. In fact, I don't even know, did I put it on your test? I think I took it off. Is it on your test?
I didn't see that one.
You should not have seen it. I think I took that one off yours. The first period had to answer that. That was extra credit, though. If you got it, it's extra credit. If you have it, it's a different, you got the first period's test version, which is fine. All right, so nucleic acids such as RNA consist of monomers of something. What are the monomers of nucleic acids?
Nucleotides.
That's right, nucleotides, that's right, they look like this. Remember I said they're made of 3 things. They're made of phosphate, and I drew it in a circle. I said from now on you're going to see a circle. It's going to have a P in it. That's phosphate. You're going to see some kind of sugar. If it's an RNA, it'll be ribose. If it's DNA, it's deoxyribose. And I said nitrogenous base, some kind of base. There's 4 of them in DNA, A, T, G, and C. I said A and T bond together, G and C bond together, and I said T is replaced with U in RNA. I said memorize that. Here's the summary. This was last week. I said make sure that you know A goes with U in RNA and G goes with C in RNA. And I said when they hydrogen bond, they're upside down. The two strands are anti-parallel. They're upside down. The hydrogen bond happens between the nitrogenous bases. I said all of that, and I drew it out, and I drew a zipper. You can go look at the video. It's already posted.
So RNA is made of
It's the same stuff. It's a nucleotide. It's just made of ribose instead of deoxyribose. So let's go ahead and answer these questions now. So in monomers of nucleotides, that's correct. So that leaves us with two options. Each of these monomers, RNA, consists of a sugar, nitrogenous base, and phosphate group. So the answer is C. This says nitrate group. Nitrate is not an option. Not an option. So this is wrong because of the word nitrate. So the only real answer you have is C. Are we okay with that? So there are 5 nitrogenous bases. There's 5 of them. ATGC in DNA, AUGC in RNA. I said 4 of which are found in DNA. What are they? A, let me underline this, or let me highlight it. Maybe that's better. Look at it. A, you know what? I'm gonna underline it. A, T, C, and G. You see it? And I drew them out. You have them in your study guide. You have them drawn out. We drew them out. We made sure we answered the questions in the study guide. ATGC. And so the answer for 21 was C. Now, why is it not B? Because you have AUGC. There's a U, but U is in what? Is in RNA. They're asking you about what? DNA. They're asking about DNA. So you always have to ask yourself, what are they asking me?
So B is RNA.
B would be RNA. If I gave you the exact same question on next week's exam, and instead of DNA I put RNA, the answer would be B. All right. Yeah. I don't know. Look on the floor. The kids, they should have brought it back.
So body practice somebody mentioned.
Somebody went to the restroom.
Who? She been doing the whole period.
Well, can you hold it for a second so let me get through this question?
Say that again?
Can you hold it for a second? Or not? Yes or no?
Not really.
Okay. I have 2 passes, they're not here. I don't know where they went. Do you see them anywhere? There should be 2. Here. Bring it back, and I want to put that one away. All right. So here we have pair bonding occurs. This, you don't have to worry about. This is a little more complicated than I wanted to give you. So I'm not going to, I made it extra credit on the test for the kids that had it. So don't worry about this. We can just ignore it. We're moving on. Which of the following best describes the form and function of one type of nucleic acid? What do we know about DNA? What do we know about RNA? DNA is let's write down what we know and what we don't know. We know DNA, we should know. We should have memorized, we should have put in our notes, we should have gone over our notes, we should have done study groups on the differences between DNA and RNA. We were told that DNA is double-stranded, has a double helix. We were told RNA is single-stranded. We were told that DNA has A, T, G, and C. We know RNA has A, U, G, and C. We were told that DNA has deoxyribose sugar. We were told that RNA has ribose sugar. We know that. We know DNA holds the genetic information. We know that RNA acts as an enzyme. RNA acts as a messenger. And it also carries amino acids. It does a lot of stuff. There's 3 functions. I think I only mentioned 2 previously. But it does a lot of amino acid. So it carries amino acids. So RNA does a lot of stuff. DNA just holds genetic information. That's all DNA does. DNA is very simple. One job is to hold the information and makes you who you are. That keeps you safe, makes you function well. It keeps your blueprint. And that's what DNA does. That's all DNA does. RNA does a lot of other stuff, but DNA only does that. So going back to the question, knowing that what we knew from our lessons, we go back to the question, which of the following best describes the form and function of type of nucleic acid? RNA is double helix, is that right? No, it is not. It's a single-stranded molecule, not double-stranded. Is RNA single-stranded? Yes, so that's fine. Functions to archive genetic information. Archive means store genetic information. No, it does not. DNA does that. DNA is single-stranded. No. So already we know the answer. It's D. Yes. And I made the same chart in the notes on the day we covered this, I think last week, Thursday or Wednesday or something. The questions on your study guide went over it. You had to actually pair them. All right? Amino acid. So when you look here, the nucleotides of DNA form blank bonds in DNA. So remember, I drew out a bunch of, I wish I could just open up that other video in a different window and keep this video rolling. But what I can do is say, I drew a bunch of nucleotides like so, and then the other had like this, and I remember I copied them, right, over and over again, and I linked them together in a chain, and I put that chain on the board, and you all said it looked like a zipper. It does. And I said, that's great, because that chain, that's exactly what we say, is that we talk about this long. I did this already once, but I said, in DNA, they're double-sided. They look something like this. And what happens is that there's hydrogen bonds between the 2 strands. And I said they're upside down, so they're anti-parallel. And these are each nucleotides, and the nucleotides have bonds between, they have covalent bonds between the 3 and the 5' ends. But the hydrogen bonds are weak bonds. So I did all that. You can go back and look at the notes. But when we look at this and we ask ourselves, what is this question asking? Nucleotides of DNA form hydrogen bonds. And the hydrogen bonds, something bonds with G. What bonds with G?
T, no.
C. C bonds with G.
GC.
So hydrogen bonds already, You know it's not oxygen. You know it's not helium. My God, 5 people chose helium. Why anyone would choose helium? Except for just sheer panic, right? Like you're running out of, your brain is you're done. I understand that. I've been there. So your brain's done, you're just going to choose helium. I get it. But there's no reason for you to choose helium. Oxygen's wrong. So we know it's either one of these two. Something bonds with G, it's C. So this is definitely the answer. And then A bonds with T. So again, the bonding rule is A bonds with T and G bonds with C. Hydrogen bonds with C. I think we have 1 or 2 more questions, so should we go and finish it? Yes? Can I go on?
What else? A bonds with T.
A, it's on the board. A bonds with T, G with C in DNA. This is in DNA.
What?
DNA.
Wait, so H don't bond with C?
No. When we talk about G and C, we're talking about the nitrogenous base. This would be A, this would be T, this would be G, this would be C. The hydrogen bonding is happening between them. Okay? All right. Can I go on? You'll see it on Thursday's lab. We're going to build it. There's a kit up there. You're going to build these molecules, so hopefully you'll understand it better then.
Oh, let's see.
Huh?
You said kid up there.
What'd she say?
You said it was
Thought you
a kid.
said kid.
It was a kid. Mr. Mendoza
Oh,
said
a
that.
kit. A DNA. There's a kid up there? That'd be creepy. That's pretty high up. All right, so fatty acids contain blank hydrogen bonds, making them this is something, again, we're going to cover next week. So you're not going to need to know you weren't supposed to know for this test. So it was extra credit. So we're not going to worry about that. This is something you should know. I just built it for you just a minute ago. Not a minute, but a few, like 10, 15 minutes ago, I built this. There's glycerol, 3 carbons, hydroxide, OH, OH, OH. Here's carboxylic acid, C double bond O, OH, C double bond O, OH. Here's the fat connected to an acid. So we're talking about a lipid. You know you should be thinking about not biglyceride. I've never said biglyceride. That's not something I said. Fatty acid, glucose, and triglyceride. That doesn't make any sense. There's no glucose in there. Mr. Mendoza's room may help you. Hobson Russell. Yes. All right, go get your photo ID. Take the hall pass. All right, so triglyceride, glycerol, and fatty acids. We haven't talked about phospholipids yet, so that's not an issue. So it's triglyceride, glycerol, and fatty acids. Those are the 3 things and how do we put them together? Dehydration synthesis. Dehydration synthesis. You take the OH of one group and a hydrogen of the other, and out comes water, just like in our lab. Now, this says image 1 below. Image 1 is this one. It's bent. Why is it bent? There's the acid group here because there's a double bond. This is an acid group. This is a fat group. It's hydrogen and oxygen bonded over and over again. And of course, this is a double bond. Right here is a double bond.
I can barely see that.
Who says they can barely see it? On the paper, you can't tell. Can you tell that it's bent and went straight?
Why,
That's all you need to answer the question.
why does that change it?
Huh?
Why does whether that change it?
Wait, why does it change? What?
Saturated or unsaturated?
Because if it's bent because there's a double bond. if there's a double bond, that means that the bonds are not full of hydrogen. So it's bent, and the bending makes this a liquid at room temperature. So number one is an unsaturated fatty acid, and it's a double bond. And the saturated fatty acid, because it has a single bond, and that's it. And let's see. So again, I just want to reemphasize that everybody's test was different, because and some of these questions were marked as extra credit. For some classes, I took the questions out completely. So we can identify whether or not a lipid is saturated or unsaturated by its physical state. Unsaturated fatty acids are blank, and saturated fatty acids are blank. Now, I've already said this in a previous lesson, and you can look at the review as well. I covered in the review. But just to make sure we're clear, when we look at fatty acids, it says the words lipid is saturated or unsaturated. The easiest example is to look at a fat, and a fat is a carbon and hydrogen, also known as a hydrocarbon. It's a bunch of carbons and hydrogens bonded together in a chain. We call that a fat. That's what fat is. Some examples of fats are lard, right? Lard, wax, right? Oils. They're all different kinds of lipids. Steroids. They're all different kinds of lipids. They're just a bunch of carbon and hydrogens. Some are in rings, some are long chains. These long chains fats, if they have something called an acid, what kind of acid have we talked about in this class a lot? Carboxylic acid, correct. If you didn't know the answer to that, this is one of those moments of reflection. I don't know the answer to that. Why is it this kid knows the answer to that and I don't? Gee, maybe I'm not doing something right. It's one of the functional groups that you were told you have to know by memory. Carboxylic acid and a fat. This part is a fat. This part is an acid. And together it's a fatty acid. That's another one of those lipids. We call that a fatty acid. It's actually pretty straightforward if you think about it. Now, what's the difference between a saturated fatty acid? This is what would be called a saturated. Why is it saturated? Again, and this is a repeat, but I'll go ahead and say it. All the carbons have single bonds. They all are full of hydrogen. Saturated means full. If you have a fat, however, if the same fatty acid, same number of carbons and everything, instead of, could you close that door, please? Thank you. If the same fatty acid, same number of carbons, instead of having all single bonds, all the bonds, remember how many bonds does carbon make? 4. That is incredibly important. That was asked of you 3 times in this test. How many bonds is carbon? I said it, 100 times in class? At least? Carbon makes 4 bonds, carbon makes 4 bonds, carbon makes 4 bonds, at least 100 times. So, and I'm not even exaggerating, you can go back and count, maybe I'm wrong, but at least 100 times is my thought. You can make, it can make a double bond, carbon can make a double bond if something leaves, and the thing that leaves is called hydrogen, it leaves, makes another bond, How many bonds is around this carbon right here? 1, 2, 3, 4, 5. So that's not right, is it? One of these hydrogens also has to leave. So you see it bends, and that bending causes issues. I told you what those, it causes a consequence, has a consequence. And what's the consequence of that fatty acid bending is that they don't sit, if I drew it just as a stick, they don't layer on top of one another the way saturated fatty acids do. So these unsaturated, these are called unsaturated. Why do we call them unsaturated? Because there's a double bond. They're kinked, they're bent. So saturated fatty acids are solid at room temperature. Where unsaturated fatty acids are liquid at room temperature. All right. There's a reason, there's just a simple cause that this is bent. So what are the examples of these? Oils, or vegetable oils. What's an example of solids? Butter. Animal fat. I gave you an example in class. I talked about frying a pork chop on a plate and having to wash the dishes. And I gave you a clear example that saturated fat is solid at room temperature. Let's go back to the question.
Did I say animal fat?
Animal, yes. Did I misspell it or something? No, it does. It's spelled correctly. It might be messy, but an animal fat. Now we go look here. It says, clearly it says, we can identify whether lipid is saturated or unsaturated if its physical state. Unsaturated fats are liquid at room and saturated fats are solids at room temperature. Well, which one of these is liquid first? This is liquid. Liquid. That's the first thing. The second thing must be solid. So the answer is B. So again, had you paid attention, had you put that to your mind, unsaturated is liquid at room temperature, saturated is solid at room temperature, you'd have this easy answer done. Waxes and steroids, I gave you as examples of lipids, so you should know they're lipids. They're not proteins, they're not nucleic acids, and they're not carbohydrates, they're lipids. Proteins, carbohydrates, nucleic acids are molecules. Proteins, carbohydrates, and nucleic acids are molecules. Molecules are the result of smaller molecules. So you take those, all three of these. So to be clear, what they're saying is carbohydrates, proteins, and nucleic acids all form chains. Correct?
Yes.
That's what it says. They all form chains. That's it. They have monomers that together they make a polymer. They're the only three that make polymers. We said, what's the only one of the four that don't make polymers? Lipids. And lipids aren't listed. So the process of linking them together, someone said it already, is correct. It's dehydration synthesis. Dehydration synthesis. Now in this video, I've already explained it, but let me do it again. I've done it in other videos as well. Let's go ahead and do it here. And say, let's say we have this molecule called glycerol. Glycerol has 3 carbons and has, I'm doing it quickly so it's going to be messy, I apologize, but we really don't have time. It really is a struggle to cover all this in class. So we have this is glycerol molecule. It's a molecule called glycerol. It's just 3 carbons with 3 hydroxides. You should all know what the hydroxide is because it's one of those fundamental molecules that you have to know. So there's hydroxide, there's a hydroxide, and there's a hydroxide, no H group. Now you're going to take a fatty acid. So what does that look like? I just drew it for you. It's a carbon double bonded oxygen, single bonded hydroxide, single carbon. Instead of drawing out all those C's, I'm going to put a line like this, remembering that at every corner of every line, it means there's a carbon. So there's a carbon here, 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 and here. So these are all carbons. Here's carboxylic acid group. Here's hydroxide. How do we link these together? This can only make 4 bonds. This can only make 4 bonds. 1, 2, 3, 4. How do we get this carbon to bond with this? How do we connect these two together? What do we have to do? I'll wait. Get rid of some stuff, right? We got to make room for it. So we have to do something like this. Hydroxide on one and hydrogen off the other, right? That's right. And then what happens is we make what? Water, just like we did in the lab. There you go, make water. And the result is the same glycerol backbone, the same carbon backbone that's going to come back up again later. You see what I mean by backbone? Is it the skeleton, right? Same carbon skeleton that we had, the glycerol molecule, except now instead of an OH here, it has a carbon it has an oxygen, connected to a carbon with double bond oxygen, then the chain of carbon and hydrogen. These, according to this drawing, these still have hydroxide on them. So you see, this is called dehydration synthesis because you're taking water out. We do the same thing every time. Every time. I did it 5 different times, 6 different ways, times 5, like 30 times on screen. I recorded, I sent it home. You did it on practice problems. I don't know what else to do. It's called dehydration synthesis. You link these together. This is a fatty acid. You can do the same with an amino acid, amine group being NH2, connected to a central carbon, connected to a hydrogen, connected to an R group. R group is a variable, also known as an R group, also known as AKA side chain. Right? Those are all words for the same thing. Connected to a carbon, double bond to an oxygen, single bond to OH. If I want to link this one to another one of these, if I want to link these two together, the amine to the carboxylic acid and make a peptide, yeah. Then I have to do the same thing. Take the hydrogen off one, OH off the other, off comes out water. Now they're linked to a peptide bond. Do that multiple times, you have a polypeptide. Over and over again. Are we good with this? Oh, you're still writing? I'll wait then. This is all review. This is not anything new. There's nothing up here that's new. I've drawn this. Does anybody remember how many times I've drawn this? I can't even remember. I've drawn it a lot. And you've drawn it a lot, and you have it in your notes. I handed it to you in a printed format, and that's the form of the study guide. You know what? You're not going to remember it, though. If you're not putting it on an index card, if you're not practicing it, if you're not going home and review, if you're going to sleep in this class right now with your head down, and you're not going home and working on this, and you know you're not working on it at home, you know it. Most of you, especially if you're going to sleep in this class, you're certainly not going home and working on this. It's not like you're laying down your head in class and then you're like at home going, man, now I'm going to get it. Now I got this. Now I got my chips. And I'm going to turn off my TV. I'm not texting. Now that I'm at home, I'm not going to text and do TikToks. No, I'm going to do my work now that I'm at home. That's not how life works, man. You get home, first thing you want to do is watch your shows, get in contact with your folks, go to sleep, eat, play, And that's what you want to do at home. Maybe your chores, I don't know. But you're certainly not going to sit there and say, now that I'm at home, now I'm going to work.
How you know? I do.
Most people don't do
Well,
that.
I
Do
do.
you do that?
No.
Right.
I go home, I want to relax.
You don't.
I don't want to work. I do when I have to, but I don't want to. I don't even like answering texts and emails at home. But if you're honest, you don't, when you're sitting in this classroom is the time you should be focused. Because you're here. All right. All right, anyways, so if we look at this, you see it's dehydration synthesis. I think that's obvious. Which protein structural component will be affected? You won't know this until next week. It'll be secondary. But you don't need to know that. I'm just going to put a red. I'm not even going to worry about it. We're running out of time, so I'm not even going to worry about this stuff. RNA and DNA differ and utilize different. Now, this is an interesting question you should know the answer to. RNA and DNA differ in that they utilize different what? Sugars, correct. Where RNA uses what? That's right. Now, again, if you're like, I didn't know that, well, I don't know what else to say. RNA uses ribose. DNA uses deoxyribose. Both of these are sugars. RNA is single-stranded. DNA is double-stranded. RNA uses the nucleotides, those nitrogenous bases, A, G, C, and U. DNA uses A, G, C, and T. A in DNA, A binds with T and G with C. In RNA, A binds with U and G with C. And when I say bind, I mean hydrogen bond. Hydrogen bond, what does that look like? Well, you have to look at a nucleotide. A nucleotide has a sugar as its base, as one of its components. I drew it on the board 3 times, 10 times. I kept saying 1 is the sugar. The next thing that sticks out is the phosphate group. Phosphate. I said I'm going to draw it like this. Remember me saying I'm going to draw it as a circle with a P in it. It's going to be a circle with a P in it. And off of this carbon over here is going to be a nitrogenous base. It's either 1 ring or 2 rings, nitrogenous base. So you have a sugar, a phosphate, and a nitrogenous base, NB, nitrogenous base. And the question is, well, you can link them together. How would I link them together? What process would I use to link these together? Who can tell me? Who's been paying attention? Who can tell me? In a second. How would I link them together? Who can tell me? How would I link these together? These nitrogenous bases, these nucleotides. Get rid of something. Excellent. What do we call that process? Dehydration synthesis. So we're going to take this, and I drew it on the board, and we all said it looked like a zipper, and there were, I must have done it like 100 times. I copy and pasted like 100 times. I made them longer and longer, and I did this previously in this video as well. And I said, look, you can have this thing, and they can be reversed, and they're anti-parallel, which means that they are reversed from each other. You have 2 strands in DNA. You have 2 strands, and they hydrogen bond with one another. They form hydrogen bonds between the two bases. They form hydrogen bonds between the two bases. One strand, I said they're anti-parallel. Go back and look at the notes. Again, if you're sitting here talking, not paying attention, taking a nap, God bless you, but I cannot slow this down anymore. We got to move on. Tomorrow we're starting the next level of this. Wow. So DNA is double-stranded. A binds with T, G with C, A with U, G with C with RNA. So now let's look at the groups. It says RNA and DNA different, utilize different sugars within their nucleotides. RNA utilizes ribose, DNA uses deoxyribose. The answer is, I hope it's obvious, it's C. I think that should be obvious to everyone based on everything I just said. And I'm posting this right now, actually. Yeah. No. Do I have a Band-Aid? Answer is no, I don't. If you have a Band-Aid, give it to the young lady. I don't have one. One of the other things I drew for you in class was this, I repeatedly drew glucose. Repeatedly drew glucose in the back. Glucose has 6 sides. This is exactly the drawing I drew with 1, 2. I even labeled them. I slowly, painstakingly said 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime. And I did the same with fructose. I said 1 prime, 2 prime. Actually, I said, what I said was, this here is the 1 prime, then 2 primes over here, 3 prime, 4 prime, 5 prime, and 6 prime. And if you see the 6 prime is connected to the front 1 prime by this oxygen. We'll look at how they're connected in a second. And then you see that this is obviously, I hope it's obvious. Even if it's not obvious, you don't need to know it to answer the question, that this is glucose, and you should know that this is fructose. But I said, even if you don't know the answer that this is fructose and this is glucose, it's irrelevant. When you look at the questions, I think it should be pretty straightforward. Identify both type of biomolecule and specific name. 2 sugars, they have to be carbohydrates because they only have carbon, hydrogen, and oxygen. If I count the number of carbons, I know that every connection between the lines is a carbon. So 1, 2, 3, 4, 5, 6. And I count the number of oxygens. 1, 2, 3, 4, 5, 6. 6 carbons, 6 hydrogens, 12 hydrogens, 6 oxygens. That's a carbohydrate. I could do that. It's 1 to 2 to 1 ratio. If I do this the same, 1, 2, 3, 4, 5, 6, and I count the number of oxygens, 1, 2, 3, 4, 5, 6. That's 6 hydrogens, 6 oxygens, 6 carbons, 12 hydrogens. Guys, that's a carbohydrate. So the monomer for a carbohydrate is a monosaccharide. When I put 2 of them together, I call them a disaccharide. So identify the type of molecule, carbohydrate. An antibody, I don't think I've talked about antibodies to you, have I? I don't think so. It's certainly not a protein. How do I know it's not a protein? What element should be in there? If this was a protein, what element should be in there? Nitrogen. And there's no nitrogen in there. I told you need to know what elements should be in each molecule. I told you that 3 weeks ago. There's no nitrogen in here. That means it can't be a protein. So that's not possible. That's out. Could it be a nucleic acid? No. Why not? Exactly right. Good. It also has nitrogen and this doesn't have it. So it's one of these two. Is this a carbohydrate? Yes. Are they both glucose? No. Why not? Why are they not both glucose? Look at it. Why are these two not both? There's two of them. You agree there's two rings? Why are they not both glucose? How do you know they're not both glucose? The shape. What about the shape? Yeah, one's a pentose, one's a five-sided ring. One's a home base at a baseball field. The other one's a hexagon. One of them is glucose. I don't remember which one's which. Who cares? You know they're not both the same, correct? So this can't be the case. They're not both glucose. They can't be. They're different. So that's not it. The only option left is B. It's a carbohydrate, and sucrose is a disaccharide. Sucrose is table sugar. I mentioned it in class. I drew it. I walked you through it. Called it a disaccharide. Told you it's glucose and fructose. Told you it was coming. This is what I drew for you in class. I do something very similar to this in class. Labeled everything. On purpose, by the way. It looked... I don't even know where the rest is. I guess it's on the previous page. Clearly labeled it in class. I said, look, this is DNA. How do I know this is DNA without even reading? Just looking at the picture. If I just looked at the picture, if all I had was this, what am I looking at? That's right, double. I love that. Somebody said it. You didn't hear it back there, but they said double. I see two. If you don't see two, I don't know what to say. So it's a double strand. To be clear, what I mean by strand. This is one strand. This is one strand. This is another strand. Do you see it's two strands? Okay, like the Velcro example I gave in class. So there's a strand there. This is one strand. This is another strand. This is what? What is this thing here? Sugar. It's DNA. We said it was DNA because it's double-stranded. So what's the sugar? What sugar is this? You should be able to answer it. If you can't answer it, again, reflective moment. What sugar is in DNA? Deoxyribose. Deoxyribose is in all these are deoxyribose. They're all linked together. Sugar, phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate. Remember me saying that? Go back and listen to the video. You hear me say that for 5 minutes? Sugar, phosphate, sugar. What do you think? I was up here having an epileptic seizure saying sugar, phosphate repeatedly? So sugar, phosphate is the connection between the nucleotides. What's a nucleotide? It's what I drew on the board a minute ago. It's the deoxy or ribose sugar. It's the phosphate. That's a P group. It's the nitrogenous base. It's the nitrogenous base. Yeah, I hear you giggling. I'm trying not to make a big deal about it. I'm trying to not, do all the paperwork that comes with you getting in trouble because you're silly and you're not listening to any of the warnings I just spent a good 10 minutes giving you. So 3 parts I told you in class. I said there's 3 parts. There's 1 nitrogenous base, and 2 there's a sugar, and 3 is the phosphate. And they're labeled here. They're labeled here. So this number 1 is what? What's this? We already said it. What is it? Sugar. What's this one here? This round one that's connecting the sugar to the other sugar. One sugar to the other one. It's a phosphate is correct. Sugar, phosphate, backbone. And what are these 4 different shapes here? that are stuck off the sugar at this point. What are these things? Nitrogenous bases. Why don't you get up there, get up and come here and sit right next to me. Just sit down right next to me. I'll talk to you in a minute. Nitrogenous bases. In DNA, they could be what? What could they be in DNA? A or C, right? One of there are 4 different bases, A, T, G, or C. If this were RNA, if it was one single strand, it wasn't a helix, it was a single strand, it had ribose instead of deoxyribose, then this would be A, U, G, and C. But in both RNA and DNA, you have 4 different possibilities. So now, take a look at what the questions are. Which one of these is correct? Is this RNA? And what I'm looking at is RNA in this diagram. No. How do you know it's not RNA? That's right. RNA is single strand. This is double strand. So this is done. This one's done. This one's done. Do you all agree on that? So that's easy. Now I only have a 50-50 shot of getting it right. Next, DNA. Number 1 is DNA. One represents a what? A sugar. We said that, right? Everybody agreed we said that. So that's right. Sugar's correct. This says number 1 represents a phosphate. That's wrong. So now, boom, I'm done. I can move on to my next question because this is all wrong as well. So the right answer, the only right answer is B. That is the right answer. Why? Because of everything we just talked about.
Are you collecting?
Yeah, you're going to put them on the table on your way out. Those are the questions.